Well, hello. So I hope the Sunday is treating you well. I know I told you guys that I would go live, but the thing is, I had something planned weeks ago at 12. So yeah, instead of going live, I'm going to ensure that this premieres at 12 as promised. As promised, I'm not going back on my promise. I got you guys. I got you all. So today we're doing csec mathematics, circle theorem, and then again next week, the other thing that I was voted on was Caribbean studies. So we're doing that next week. I don't think this really matters. So you guys guys are doing CSEC. So Cape Caribbean studies next week. Tell a Cape friend if you have one. Anyways, again, as usual, if you're new here, some housewarming, go over to Instagram and follow me at young_genius.official. And I made it easy for you. Just scan that QR code with your phones and it takes you right to the page. If you need to contact me, you can email me at younggenius.educate@gmail.com, and please take note of the two G's, YOUNG, and the genius, GENIUS. All right. And if you need to get me on WhatsApp, the number is 876-501-1966. That's 876-501-1966. You can find me on Facebook, Instagram, and YouTube at young_genius.official, Young Genius Official on YouTube. And you can always go over to my website at younggeniusofficial.com. Made some updates over there. Some past papers are available. So go over there and check it out. Yeah. So let's start without any more delays. Circle theorem. It's one of the most popular questions asked on the csec mathematics past paper. So it's very important that you have an idea of what you're doing. If you know it really well, then you're set, right? So first and foremost, I must introduce the term subtended. Most teachers don't. So when it comes on to identifying the rules, you're not really sure what you're doing. So the word subtended means that the angle is open to the same points. So if you take, for example, this line segment AB, a line segment is simply a line that starts at a certain point and ends at another point. So this is point A and this is point B. And if I draw a line from A to B, then that's a line segment. Now, if you take that line segment AB and you take note of the first angle, that angle is in green, and I called it angle A. Angle A, as you can see here, opens to the point, it starts here and it opens to here, right? That's angle A. Then the other angle B starts or opens on the same point and ends on the same point. So that's angle B. So seeing that both angles open to the same point, we can say that it is subtended on the line segment AB. So subtended simply means that A, the angle opens or both angles open at the same point, all right? And it's the same thing when they say that angles are subtended on an arc. If you have an arc, which is a part of a circle, and the angle happens to open like this, and you have another angle. I'm changing the color so you can keep track of exactly what I'm doing. And you have the angles like that. They're at the same, they start at the same points, so they're subtended on the same arc. And that arc would be this portion right here. So they're subtended on that portion of the arc, right? So it's very important that you understand what the word subtended means when you intend on doing a circle theorem question. And also there are some rules that you need to know, some circle theorems that you really need to know by heart in order to complete these questions efficiently and accurately, okay? It will also require some additional knowledge, but wherever that is concerned, whenever we're doing the practice questions during this session, I'll be sure to mention those extra rules if they come up. All right. But the key to doing math is really just practice, practice, practice. So if you find that you're having trouble with something, do 100 questions. Trust me, 100 might sound a lot, but it really isn't that much. So let's look at the first rule. So rule 1 says that, and don't get me wrong, I just listed the rules in a specific order. There is no rule 1, rule 2, rule 3, right? First rule that we'll be covering today, right, is this one. The angle which is made between a tangent and a radius of a circle, or the radius of a circle, is equal to 90 degrees. That's always the case. Now you know that the radius is a line drawn from the center to any point on the circumference. So an example would be from point O here, the center, all the way down this green line. That's a radius. Now a tangent is any line drawn on the outside of the circumference of a circle. And so here we have a tangent. So whenever you have a radius meeting a tangent, the angle formed between those two lines definitely going to be equal to 90 degrees. So right here, 90 degrees. So if I even take myself and do this, forgive if my lines aren't really straight, I don't have a ruler in this program, and I draw a tangent like that, then the angle right here, you guessed it, 90 degrees. Can even do the same thing over here. Don't really matter. Like that, pull a tangent. Hey, hold on, let me fix this line. So, all right, last try. Stay with me. Nice. That's good enough. I can say that's good enough. 90 degrees. 90 degrees. Right? 90 degrees. So that's just a given. So angle OAC, that's the original starting from, and when we have 3 letters like this telling you that this is an angle, it's in the same order. So O is a point in the circle, A is another point, and C is another point. So if you play a little connect the dots, O, A, C, this angle right here is angle OAC, right? So I'm also teaching you how to identify angles. So OAC is equal to 90 degrees. The second rule here says that 2 tangents on a circle, which meet at a point outside the circle, have the same length. So that means that if you're supposed to move from point A to point C, remember a tangent is a line outside the circle, right? That falls at some point on the circumference. So if you're supposed to move from point A to C, and let's say that is 5 centimeters long, then from B to C, seeing that they both end at point C, is 5 centimeters as well. So the indication that these lines are equal can sometimes be shown by some lines looking like this. And also, from point O here, I hope you got that tangent thing. Now I'm going to show you something else that you can notice. From point O here, right? Point O is always the center of the circle. So from point O to any point under this the circumference, this here is a radius, right? So by right, you know, you already know some things about this circle, right? And it's the same thing for this other green line over here. It's also a radius. It goes from the center to a point on the circumference, and that's always equal. So here we have a double line showing that these 2 lines are equal. Now you also know something else about this circle. You know the angle right here. Why? Because of rule 1. And what did rule 1 say? All right, good, good. Hope you got it. The angle formed between a tangent and the radius of a circle is equal to 90 degrees. Good, 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 good. Really should check. Good. So now the third rule that we'll cover is that the angle in a semicircle is a right angle. So often a mistake made by students is to assume that as long as a line goes like this through the circle, then it's going through the center. That really isn't true. Whenever there is a center in the circle, or whenever a line passes through the center, it will be always identified by a point, and most times it is labeled as O. Sometimes if they're feeling cheeky, they might change the letter which they label the center with, but it's always identified. So if you happen to see a line going through the circle and it really isn't identified as the center, like them really never just tell you say at the center, then don't assume that it's going through the center. That's a very good way to get the question wrong, right? So don't assume. You need to be dead sure about certain things, right? So here, if you realize this line going through the center, that's a diameter, it cuts the circle in half. Now the line formed, or the angle formed from there and touches the circumference here, is always 90 degrees. So then you can even go ahead to work out these angles over here, because this is an isosceles triangle. So that means that the sides here are going to be equal, and so will the angles. If the sides of a triangle are equal, the angles at the base are equal as well. All right? So I hope that's clear. If you have any questions, let me know. Okay? So, anything else I need to add about this? Let me think. Don't want to shortchange you. I think that's it. So, oh no, all the angles in a triangle add up to 180 degrees. That's important. So all the angles in a triangle add up to 180 degrees. So if this angle here is 90 degrees, then let's call this angle C and angle A, and no, angle A and angle C. Let's do that. Let me erase and clean it up. Just don't write over my mistakes, because I want this to be very clear, very clear. So yeah, let's say we have that. Now, if B is equal to 90 degrees, then B plus A plus C must be equal to 180 degrees, because those are all the angles present in the triangle right now. You have B, which we found to be 90 degrees because of the rule that we just did. We don't know the value of A, and we don't know the value of C. But what we do know is that triangle ABC is an isosceles triangle. So that means that the angles at the base must be equal. So let's call these angles X then, right? I'm just using random letters. You could use any letter you choose. It doesn't really matter, so don't get confused by letters now. Letters represent real numbers in math, right? So it don't really matter what letters you want to use. Just use any letter, right? So now that they're equal, we can say 90 degrees plus X plus another X, because they are the same, is equal to 180. And now an exercise that when I'm teaching algebra, I like to use is ask you the question and I want you to answer in a complete sentence. If you have one pencil and I give another pencil to you, how many pencils do you have? I'm sure you got that. You say, I have 2 pencils. Exactly, that's how I want you to answer. So if I have 1 pencil and I get another pencil, I have 2 pencils. Let's try it with another scenario. If you have 2 candies, 2 mints, let's say you have 2 mints, and you go to the store or shop and you bought 3 more mints. How many mints do you have? Pay attention to the words. If I have 2 mints and I go to the store or the shop and I buy 2 more mints, I now have 5 mints. All right, watch this now. If I have 1 X and I give you another X, how many X's do you have? I have, just add it just like the candy. I have 2 X's. All right, nice. So that should clear up a bit of addition and subtraction of algebraic terms for you. Just a bit. Now go teach you everything in one day. So now we have 2 X's, and that's equal to 180 degrees. Now transposition. You have 90 over here, and it's positive 90. And in order for you to make X the subject, you really need to get rid of this 2 from this side of the equal sign, meaning the left side, and this 90 degrees right here. So to do this, let's work with breaking up the terms first. 2x is a term, 90 is a term, and 180 is a term. Terms are divided or separated by addition, subtraction, and equal signs. So when you're doing math, what you need to do is get the terms by themselves, right? When you're doing transposition, most students would go ahead and divide by 2 on both sides. But first, you need to get rid of this 90 because you can think of it like a security guard or something blocking that 2 from moving, right? Can't move the 2 before you move that plus sign, right? So to do this, 90 is positive. So we'll subtract 90 from both sides. So minus 90 plus 2x is equal to 180. And that's still degrees, right? Minus 90. 90 minus 90 is equal to 0. Now I'm going to write the 0 just for now. But usually I just cross them out because there's no need to write the 0 because it don't really value anything. So now we have plus 2x, right? And 0 plus 2x is 2x, is equal to 180 minus 90. That's 90, right? So I'm going to start writing up here. 2x is equal to 90. Now 2x is the same as 2 multiplied by x. Whenever we're transposing, in order to move something to the opposite side of an equation, you have to do the opposite operation. Meaning, if something is positive and you need to move it to the other side of the equal sign, you have to subtract it. And if you're subtracting, or if the number is negative and you need to move it to the other side of the equal sign, then you need to add it. Here now, if you're multiplying something and you need to get it to the other side of the equal sign, you have to divide because the opposite of multiplication is division. And if you're dividing something and you need to get it to the opposite side of the equal sign, you need to multiply because the opposite of division is multiplication. So just write that down if you're not going to remember it. Write it down. It's good to write notes, right? Like little pointers when you're doing math to tell why you do something, right? So we're multiplying 2 by x, so we're dividing by 2 on both sides. Now 2 into 2 is 1, 2 into 2 is 1. So now we have 1x, and we don't write ones in math, so we write x is equal to, and 2 into 90 is 45. So that means one of the angles, angle A here, is 45 degrees, and the one over here, C, is also 45 degrees. Okay? So that's a way to work out angles. So that was rule 3. The angle in a semicircle is a right angle. So I hope that's clear. Now, rule 4. Now, two angles which are subtended by the same arc. The angle made at the center is twice as large as the angle formed at the circumference, right? Now, here we go again with this word subtended, what it says by the same arc. Now, identifying the arc right here. The arc is BC. Both angles start at that point. So you have two angles right here. You have angle BAC, which I labeled as X, right? And you have BOC, because we're moving from point B to O to C. That's why it's called BOC. That's equal to 2x, right? So if you look here, angle BOC is 2 times the angle BAC, right? Or it's 2 times x, all right? Because BAC is x and BOC is 2x. So if you want to write it like this, angle BOC is equal to 2 times x, right? That's also acceptable, right? Now, subtended on the same arc, both angles open on the same arc. That's why it says subtended. Now, sometimes CX is going to stretch this second one all the way past the circumference of the circle. Because they open at the same point, the angles are actually equal. And you can test it or prove it, right? I think I have an example with it. If not, I'm sure you'll see it one day. Now, for rule 5, angles which are subtended on the same arc at the circumference are equal. And another way you can say this is angles in the same segment are equal. So if you look right here, I'm going to use different colors to highlight these angles. If you look right here, the starting of both angles are on points B and point C. So they are actually subtended on the same arc. The arc is right here, so the arc is BC, right? They're all open on the same arc. Them just looked flipped. They look flipped, right? That's the only thing. But if you pay close attention, you'll realize that they open on the same arc. So if the value of this angle is x, the one here is x as well. And it's the same thing in the opposite direction, actually. But I won't label it, right? So I don't want to confuse you. So angles in the same segment are equal. They look like this, right? Now this one, in a cyclic quadrilateral, and a cyclic quadrilateral is a 4-sided figure where all its vertices or points of connection touch the circumference. Now, if it just happened that only 3 points touch the circumference, it is not a cyclic quadrilateral. In order for it to be considered a cyclic quadrilateral, all 4 points have to touch the circumference at a certain point. It doesn't matter where. them just have to touch, right? So this would be all typo on my part. Push. Now, the rule is opposite angles in a cyclic quadrilateral add up to 180. So if this is an angle X and this is an angle Y, they're opposite to each other. So X plus Y is equal to 180 degrees. And if I happen to label this P and this Q, P plus Q is equal to 180 degrees as well, all right? Because they are opposite to each other. Now, rule 7 says the angle formed between a tangent and a chord. A chord is a line segment that touches 2 points on the circumference without passing through the center, right? So here, well, that's not true, no, because if you have it passing, the radius or the diameter is a chord that passes through the center. So basically, a chord is a line segment that touches 2 points on the circumference. So an angle that is formed by a tangent and a chord is equal to the angle in the alternate segment. And a very easy way of identifying the angle in the alternate segment is to look at the angle formed on the chord. Now, if you look right here, and I only discovered this after doing this like 50 million times. If you look right here, this is our tangent and this is our chord, right? And the angle, of course, will be formed between here. Now, if you look right here, you will realize that an angle opens on that chord right there. So whenever you have an angle opening on a chord, that is the angle you're looking for in the alternate segment, okay? So the angle that opens on the chord is actually the angle in the alternate segment for the angle formed by the chord and the tangent, all right? That's a good way to find it. And I hope me using different colors to identify these things is actually helping, because it would be an actual disaster if they weren't helping at all. So that's rule 7. So if here is X, then here is X as well. And if this X is 60 degrees, that means the angle right here is 60 degrees as well. And it's the same way BAC. We start at point B, we go to A, then to point C. So that angle right there, right, is equal to B, go to point C, D. So B, C, D. All right. So I hope by now you're pros at identifying angles. So it's time for us to try some questions. Isn't that nice? Now I'm going to hide the floating meeting controls. I don't think you could see it anyways. I'm using Zoom to record because file is way lighter to handle from my computer and it will be processed quick, and I need this to be processed quick. So diagram below, not drawn to scale, shows a circle with center O. I told you, if they don't identify it, don't assume that you know where the center is. They will identify it for you. So it has the center O, and the line DCE right here is a tangent to the circle. And they also told you that angle ACE right here, ACE, measures 48 degrees. And angle OCB, right, B, is 26 degrees. So that's what we know so far. Let me clean up my highlights so we can go ahead and start solving the angles. The first question wants you to And also in the order in which they're given, you can always figure out the angles in that order. Of course, you can use other things to help you. I mean, you can find another angle before doing this one, and it will be perfectly fine. So angle A, B, C is what we need to find out first, which is this one. Now you could even go ahead and solve this, then this, and this, and figure out angle B, right? Or angle ABC. But you don't have to go through all of that to figure it out. You can use one of the theorems, and especially if they're going to ask you to give a reason for your answer, then, you know, the theorem would be the way to go. Now, if you look right here, no, if you look right here, you must or hope you realize that we're talking about angles in an alternate segment. So if you look at angle ACE, angle ABC opens up to it. Let me change the color. Row ACB, I needed to change the highlighter thing. Now B, oh, this angle right here, ABC, opens onto that chord formed by the tangent and the chord, right? So that must mean that if ACB is 48 degrees, then ABC is what? Hope you got it. I'm going to write it now. 48 degrees. Very good. So that's 48 degrees for you. Now angle AOC rather. So we're looking for this one. Now remember, angle at the center is 2 times the angle at the circumference. So that means that angle AOC is equal to 2 times 48 degrees. So that means angle AOC is equal to 80 to 816, 56 degrees. Put that in a calculator and tell me. 2 times 48. All I had to do was add 48 to 48, you know. I'm sure it's 56 now that I thought about it that way. Lies, it is 96. Oh, I forgot that I said 8. 2 4 is 8. I thought I said 2 4 is 6. 2 4 is 6. No, sir, 2 4 is 8. So this is 2 times 4 is 8, 80. 2 times 8 is 16. 80 plus 16 is 96. So that means that this angle at the center here is 96 degrees. All right, I hope you got it. Now, if we look for BCD, the angle right here, that's what we're looking for. We have another angle in the alternate segment, but how are we going to get to this one? How are we going to get the answer for this one? No, I'm assuming that it's 48 degrees, but I can work it out and check, right? Because these look like opposite angles to me. And this looks like the same thing, but I can't just assume that. I have to work it out. So how can I do this? I see a way. If you look right here, this is a radius, and this is a tangent. So we know that the angle formed between a radius and a tangent, which would be this one, is 90 degrees. And if we already have 48 out of the 90 degrees, we can figure out the size of this tiny angle in here. Let me just shade it, the angle right there, right? By simply subtracting that 48 that is already there from 90 that we have in total. And that would be 42 degrees. So we know that that part is 42 degrees. We didn't even have to work it out just yet to find this. New rule that you need to know, angles on a straight line add up to 180 degrees. So if I added 90 and 26, right? 90 for all of here, 26 for right here, and subtract that from 180, I would now know the angle right here. Because let's say 48 plus 42, that's 90 degrees, plus 26 degrees, plus our unknown, which I'll call x, is equal to 180 degrees. So we're doing the same algebra, right? 90 plus 26, that is equal to 116 degrees, plus x is equal to 180 degrees. And I'm giving you the opportunity to practice transposing and making different things the subject of an equation. So we need to make x the subject of this equation. So we have positive 116. So to get it to the other side, what you need to do? The opposite operation, which is to subtract. So 116 minus 116 plus x is equal to 180 minus 116, because what you do on one side, you definitely have to do to the other side, right? So that means that x is equal to 64 degrees, right? So you see how easy it was for me to assume that it would have been 48 because it look alike, right? But that's definitely not the case. It's actually 64 degrees. So always go do the length, work it out, right? Now they're asking for angle BAC. Now, again, this is an alternate angle. Let me label it for y'all. Let me take away that. Let me take it away. Now we just found BCD. And now they're asking you to tell what is BAC. BAC opens, the mouth of BAC opens onto BCD. Let me use another color just so you can see it, right? What I'm talking about. So that means that this angle is in the alternate segment. So this and that is equal, right? So that means that BAC is also 64 degrees. All right? So hope it's all clear. Hope it's all clear. Now OAZ. OAC is what they want you to find now. I already found OAC earlier, you know. But hold on. Let me just label these. It's getting a bit messy, but see with me, I beg. 64 degrees for that one down here. Now we're looking for this angle, the smaller angle of the two. Now the whole thing right here is 64 degrees. But again, this is an isosceles triangle. Why? Point O is the center and it goes from O to A. So OA is a radius. And so is OC, right? Line OC. So that means that they're both radii, so them have the same length. That means that this is an isosceles triangle. And remember, the angles at the base of an isosceles triangle are equal, right? Hope you're following. So that means this angle right here, the one that I'm blocking out in red, I hope you see where I'm blocking, is equal to the angle here, the other one that I'm blocking in red. So these two base angles in your isosceles triangle. Now, in case you didn't identify it, let me change the color. I'm going to block it in blue, right? So this angle down here equals this angle right here, all right? So remember, angle formed between the radius and a tangent is equal to 90 degrees. So if we subtract 48 from 90, we'd be able to get this 42 right here. And if this over here is 42, that means this on this side here, again, is also 42 degrees, right? So that means that angle OAC is equal to 42 degrees. These are all 1-mark questions, right? And the last one is OAB. Now, remember, we found that the whole thing right here is 64. And just this little piece in the triangle here is 42. So it's like looking at a pie. You have one whole of pie, and let's say you take out this much out of the pie. You've now removed a quarter of the pie, so that leaves you with 3/4 left. So we're going to do this now. If we have 64 degrees and we take one of self and we take off 42 degrees from it, so the whole thing is 64 degrees, and we take off 42 degrees, then that means what is left is equal to 64 minus 42. And 64 minus 42 is 22, right? So that means that the angle OAB, the little piece right here, is equal to 22 degrees. And that's the answer for the whole part of this, right? So I hope these were clear. Going to some more practice though. Same thing, the angle not drawn to scale shows a circle with center O. I prefer the yellow highlighter. The line UVW is a tangent down here, and ZOXW is another straight line, and angle UOX is equal to 70 degrees. So that's what they've given you in the brief. Usually it's important. I don't know what you want to use it to do, but I know what I'm going to use it to do. So calculate showing working where necessary the measure of the angle OUZ. So OUZ, this one. Now, easy way to do this is to look at the angle here. This is 70 degrees. And if you look right here, we can actually make a complete circle, right? We can make a complete circle. Now, a complete circle adds up to 360 degrees. So a complete turn is 360 degrees. And we're going to use this to figure out some stuff. We have 70 here. We have 70 here. I'll label this X and this X because they're the same. Opposite them, they're the same. They have the same because they're the opposite, right? So 70 plus 70 plus X plus X will add up to 360 degrees because that would be a complete turn. Turn through this angle, turn through this, turn through this, turn through this, and eventually turn again to get back to the same point we started out at. So it's a complete circle, right? One complete circular motion. 70 plus 70 is 140. And X plus X is 2X. So now we have this to work with. 140 plus 2X is equal to 360. See if you can work this out before me. I'll give you a bit of time. I'll wait a bit. Not like whole day a bit, but a bit. So remember the rules of transposition. Do the opposite operation to get what you don't need on the opposite side of the equal sign to solve for X. All right, let's remind you of the first step. This is 140. We need to get rid of this to unblock this 2. So since you're adding 140 on this side, or it's positive 140, to get it to the other side, you have to subtract 140 on both sides. So 140 minus 140 plus 2X is equal to 360. minus 140, right? 140 minus 140 is 0. So now you're working with 2x is equal to 360 minus 140, which is 220, right? Now, how would you solve for x? Remember, 2x is 2 multiplied by x. Nice, so you need to do the opposite operation, which is to divide by 2. So x is equal to 110, because 22, 1, 22, 1, and 2 into 0, 0. So x is equal to 110 degrees. So that means that right here we have 110. This is an isosceles triangle. And remember, we're working for this right here. So if that is the case, how do we know that it's an isosceles triangle? You're definitely sure that line OZ is the same length as line OU because they're both radii. They start at the center, circle, center O, right? And they go to a point on the circumference. So if that is the case, and all angles in a triangle add up to 180 degrees, then 180 minus 110 will give you the size of these two angles, y plus y, which is 2y, two of the y angles, right? Using random letters, don't worry. So 180 minus 110 is 70. And that's equal to 2y, right? We divide by 2 on both sides. 70 divided by 2 is 35, right? So that means that OUZ is equal to 35 degrees. So y equal 35 degrees. This is about to get messy, man. Now, UVY, right? UVY is what we're looking at now. UVY. UVY right here. No, things that you can figure out from this. I need to change the color so you don't really get confused. Found out that right here is 35 degrees, and we're going to need this. We know that an angle formed between tangent and a radius. Now, these are two radii connected to make a diameter. Still the same thing, right? Goes to the center. This angle here is 90 degrees. This angle up here is 35 degrees because it's an alternate. It's in the alternate segment. So right here, and you can even call it what we call a Z angle. So it forms like literally the letter Z. Let me do this in blue. So from here to here, from here to here, from here to here. See, it looks like the letter Z. So I'm definitely sure that if this is 35 degrees, then the one over here is 35 degrees as well. And this one right here too would be 35, and this one would be 35, right? So it's all 35, all 35. What we're looking for is this one right here, UVY. Now remember, angles in a triangle add up to 180. So if I label this angle V, 90 plus 35 plus angle V should equal to 180 degrees. So you can go ahead and solve for V. So 35 plus 90 is equal to 125 plus V, and that's equal to 180. Now, going to subtract 125 from both sides because this is positive 125, right? Numbers can either be positive or negative. So if it's a minus sign that was before it, you would add the 25 to both sides, all right? But seeing that it doesn't have anything in front of it, you assume that it's positive, right? So 125 minus 125 plus V is equal to 180 minus 125, right? Whatever you do on one side, you do to the other side. So V is equal to 180 minus 125. That's 55 degrees. So that means that this angle right here is equal to 55 degrees, right? So we can go ahead and insert that as our answer. So UVY is equal to 55 degrees. Now, UWO, this one right here, we need that. Can use the same triangle thing because we know this is 70 right here. Right here is 70. We know this is 90. So we can work out this because we know that angles, we can work out angle W. Angles in a triangle add up to 180 degrees, right? So that means 90 plus 70 plus angle W will equal 180 degrees. So 90 plus 70, that's 160, plus W is equal to 180. Now you'd subtract 160 from both sides. So W would be equal to 180 minus 160, which is 20 degrees. So now we found this to be 20 degrees. So we know the answers are 35, 55, and 20 degrees, right? Okay. If you have any questions, send them to me. All right, let's look at another one. I think we have quite a few, but no worries, see, and then we'd be done, right? So, 3 more, and then we're done, all right? So bear with me. Just need to practice. So the diagram below, not drawn to scale, shows a circle with center O, and EBC is a tangent to the circle. So again, even when I'm doing my exams, I like to underline with my pencil important details. So circle with the center O, so it's labeled O. EBC is a tangent, right out here. So, and angle OBA is 40 degrees, and OBF is 45 degrees. 35 degrees. 35. All right. So now they want you to find EBF. No, EBF would be right here. Right? Right here. That's EBF. No, I hope you've seen it before me. Please. Right here, we have a radius and a tangent. So that means that this measures how many degrees? 90 degrees, right? The whole thing. So if that is 90 degrees and we know that this portion here is 35, we can take out the 35 degrees from the 90 degrees to get angle EBF. So that means that angle EBF measures how many degrees? Nice, 55 degrees. So we can put that in just for records. All right. So 55 degrees. Next one is BOA. Now BOA, how will we find this one? There are many ways in which you can find it. I'm going with the easiest. This one here, we know this is an isosceles triangle because OB is a radius and so is OA, so they have the same length. So if they have the same length, that means that it's an isosceles triangle. And the bases of the angles at the bases of isosceles triangles are equal. So if this is 40 degrees, then over here is 40 as well. And that means we can find the angle right here, BOA, right? Angles in a triangle add up to how many degrees? Good, if you're paying attention, you know it's 180. So that means that, let's call this angle O. O plus 40 plus the other 40 degrees in that triangle must add up to, O was a bad choice. I'll change this to a P because it looks like 0. So P plus 40 equals 180. 40 plus 40 is how much? 80. Nice. So P plus 80 is equal to 180. Here you can actually see the plus sign now, which I'm glad. So you know that plus is in front of this 80. So in order to move this 80 to the other side of the equal sign, so P alone will be left, you have to subtract 80 from that positive 80. And whatever you do on one side, you do on the other side. So we have to subtract 80 over here as well. So 80 minus 80 is 0. So P plus 0 is P. And that would be equal to 100 degrees, right? 180 minus 80 is 100 degrees. Now we have AFB up here. Hope you remember the theorem. What's the theorem? Please tell me the theorem. Isa. Da. All right, 100. So the angle at the center of a circle is 2 times as large as the angle at the circumference. So that means that the angle AFB has to be half the size of the angle right here. So if this is 100, then half of 100 is 50. So that means AFB is 50 degrees. Good. All right. Now we need to find out the value of this tiny angle right in here. So OAF. O, identify it. AF. I'm giving you time to see where I'm at. OAF, right? No, this is one huge triangle right here. Nice, right? You have a triangle. Now we know the size of the angles here. This is 35 and 40. We add that up, we get the angle for here. We know this is 50. And so this plus this will, if you add up all of this now, you get 180, right? So if I write it out, 50, I'm starting from the top here. 50 plus 35 and 40, 35 plus 40 plus 40 plus the unknown. I'll write A for the unknown, this little one right here, should all add up to 180. That wasn't an equal sign at all. Should be equal to 180 degrees. So go ahead, add it up. 50 plus 35 plus 40 plus 40 again. That's 165 plus A is equal to 180, right? How would you solve for A? Nice, 165 minus 165 plus A is equal to 180 minus 165. 165 minus 165 is 0. So A is equal to 180 minus 165. And that is equal to 15 degrees. So we have 15 degrees to work with right here, right? Okay. All right. I hope that was clear. Let's look at the other one. And then we have Like the last one, I really enjoyed looking at that one. Like I saw it and it did look like it hard. So I'm like, let's do this one. Let's do it. Right? So the diagram below, not drawn to scale, shows. What does it show? It shows a circle with center O. SGH is a tangent. SGH is a tangent to the circle. Angle FOG is equal to 118 degrees. And angle DGS, right here, so DGS, 65 degrees. We have a lot to work with, don't we? And I'm seeing a cyclic quadrilateral. 1, 2, 3, 4. Let's see if we'll need it. Now they're asking us to first calculate OGF. OGF. No, you know, I like that them say OG, because by now you must know how to identify radii. So here, that's a radius, that's a radius. So what type of triangle is this? If you never identify the radius, you must tell me no, what type of triangle is this? Good, nice. You got this. Isosceles, so that means that the sides are equal, therefore the base angles are equal as well. And if this is true, let's call this X and this one X because they are the same. Triangles in a triangle add up to 180 degrees. Nice. That means 118 right here, so angle O plus X plus another X at the base is equal to 180 degrees. So 118 plus X is 2X equals 180. So what's next? 118 minus 118 plus 2X equals 180. I hope you're picking up the patterns. I deliberately chose questions where we're repeating the same thing, right? 118 minus 118 is 0. So 2X is equal to 180. And remember, algebra, we don't really write multiplication signs to that extent. So 2X is the same as 2 multiplied by X. So what's the opposite operation for right here? Nice, we're dividing by 2. So you put your fraction bar, divide it out. 22, 1, 22, 1. X is equal to half of 180, which is 90 degrees. So that means I forgot to do something, and I hope you realized it. It don't make sense at all. What did I forget to do? Let's go back up. Nice. Forgot to subtract 118. Nice. So 180 minus 118. So 2X is equal to 180 minus 118. And that's 62. Now we're talking. Now we're going to divide through by 2. Now that we fixed that error. 22, 1, 22, 1. And 2 into 62, 26, 3, and 22, 1. That's 31. So X is equal to 31 degrees. So see how it's easy to slip up? So now that we found that as 31 degrees, we can go ahead and do D, E, F right there. So, right? How are we going to do this now? How are we going to do this? How are we going to do this? First, we can figure out what's the size of the angle right here, because this is a radius, this is a tangent, and what do you know about angles formed by radii and tangents? 90 degrees. Nice. So if this whole thing is 90 degrees and we know that this piece here is 65 out of the 90, we can figure out right here simply by 90 minus 65, right? So 90 minus 65 degrees is 25 degrees. So we found out that here is 25 degrees. And we found out that right here is 31. So we now know the size of all of this. This would be 25 degrees plus the 31 that we just found. And I'm sure I wrote 35 down here. I don't know why I'm slipping up so much now. Please forgive me. I'll be more careful. This is 31, right? 31. Nice. So 25 plus 31 is equal to what? 56 degrees. Nice. And what do you, if this here is 56, right? What do you know about cyclic quadrilaterals or angles in a cyclic quadrilateral? And why is it cyclic? Because all 4 points touch the circumference. Angles in a cyclic quadrilateral add up to 180 degrees. So that means that 56 degrees plus E will be equal to 180 degrees. Nice. That means that 56 minus 56 plus E equal to 180 minus 56. E would therefore be equal to 180 minus 56. You got this. 124 degrees. What you know? You this, right? Nice. So this is 124 degrees. Now to the nice one. This one, A. Promise you, it's not as hard as it looks. It's not as complicated as you think. First, read the question, take out what's important, and think about it, right? Take it in small parts. Don't try to tackle everything at once. That's how you do hard questions, right? You break it into parts, break it into smaller, manageable pieces, work it out step by step, right? You know, it's kind of when I reach the bridge, I cross it kind of thing. So this diagram shows 2 circles this time. And the center, C is the center right here of the small circle or the smaller circle. GH, G right here, so H, a line, is a common chord, meaning it's a chord in both the larger circle and the smaller circle. I hope you can see it because this is a circle, that's a smaller circle. This here is the larger circle. Forgive my circle. And the chord is inside both of them, right? So that's why it's a common chord. All right, let's clean up. Now, DEF, DEF is a triangle. And angle GCH is 88 degrees. Wrapping up, right? Don't fall asleep. Concentrate for this one. GHE is 126 degrees. GHE, 126 degrees, right? First question, calculate given reason for your answer. Working is reason as well. The measure of angle GFH first. All right, GFH. I know you have this one, you know. You have it. This one, GFH. Angle at the center, angle at the circumference. Good. So this is 2 times the angle at the circumference. So the one at the circumference must be half of 88, which is good, 44 degrees. Now G, D, E, right here. As I said, it's not as complicated as it looks. This is a cyclic quadrilateral. Why? the vertice touches a point on the circumference of the larger circle every time, right? So that means 126 and this angle are opposite angles, right? And what we know about opposite angles in a cyclic quadrilateral, they add up to 180 degrees. So that means D plus 126. I don't want to skip a step. I usually skip writing out all of this. Just subtract same time. D plus 126 minus 126 is equal to 180 minus 126. 126 minus 126 is 0. So that means D is equal to 180 degrees minus 126 degrees. And that is nice 54. 54. So we found that GDE is 54 degrees. Now DEF is what they want us to find. Found this to be 54. DEF is a triangle as well. DFE or DEF, whichever way you want to go. So this is 44 up here. This is 54. And we need to find the one right here. We know that angles in a triangle add up to 180. So 54 plus 44 plus angle E right here equals 180. And again, I'm using random letters. I just used E because E is right here, right? So it's easier to follow, but you can use any letter. You're not going to get marked for whichever letter you choose. If you like to use P, right? So 54 and 44 is equal to 98 plus E is equal to 180. Now 98 minus 98 plus E is equal to 180 minus 98 because you have to subtract 98 on two sides, right? To keep the equation equal. So now 180 minus 98, that's 82 degrees. That means that this here is 82 degrees. And if you add it up, 82 plus 54 plus 44, you should get 180. If not, you answer wrong. All right, so I hope these were clear. This has a second part, which which I promise you really isn't a terrible thing. So using 3.4, pi as 3.14 in this part of the question, given that GC is equal to 4 centimeters, calculate the area of, number 1, the triangle GCH. All right, GCH is this tiny triangle here. I'm going to put it in blue, highlight it in blue so you can see it. And now by now you must be able to tell that I really like the color blue. So angle GCH, triangle rather, GCH is here. And the GC is 4 centimeters. It said centimeters, right? And not meters. Yeah, man. 4 centimeters. So we now know that the radius of this circle, the smaller circle, is 4 centimeters. Now, to calculate the area given angle C here, it don't really matter if it's angle C, you're given an angle and you know the value of two sides. So let's say this is, all right, I'm going to change the angles for the sake of the normal equation that we usually use, right? So this is A and I'll label this B, right? This means that this is angle B and this is angle A, right? This would be angle C. Now the opposite side to the angle would be the side. So this is side A, this is side B, and sides are usually in common letters. And this is side C, right? So the side is always common letter opposite to the angle. Now to find the area of a triangle like this, you use half AB sine C. It's different from the half AB h, or half base times height equation that you usually use, because you use those for right angled triangles. So always know this. You use half base times height for right angled triangles. So you also have two other formulas that you can use to find the area. You have Heron's formula and another one. I don't really remember it right now, but they always come at the front of your CXC papers. On that formula sheet, you'll see area of a triangle, and they give you like 50 equations for the area of a triangle, right? And they're kind enough to tell you which one is for which, right? So right angle triangle, half base times height. I think that's the first one. You have Heron's formula. You have this half AB sine C. So you're going to put this into your calculators. Half multiplied by 4, because side A is 4 centimeters. That's the first radius. Times another 4, second radius, that's side B, multiplied by the sine of the angle, which is 88 degrees. So if you put that into your calculator, half times 4 times 4 times sine, SIN, 88. And you need a scientific calculator to do this and ensure that it is in degrees and not radians mode. So if it's in degrees, if you look at the top of your calculator and see D, a little d. So you should get 7.995. I'll just write 8.0. Round it up. So 8.0, don't forget your units, centimeters squared, because it's area. So we found the area to be 8.0 centimeters squared. Now you need to find the area of the minor arc bounded by arc GH and radii GC and HC. GC and HC are radii, right? The radii that we found to be 4 centimeters. It's a bit messy, but stay with me, right? Hope you're following. HC, GC, radii, and then the arc GH. So that forms a sector, which is a part of a circle. Let me highlight that in green maybe, so you can follow. So all of this right here, this sector, that's what we need to find the area of. And to do that, we will use the formula theta, which is the angle at which the sector covers, over 360 degrees. So that's a part of the circle multiplied by the area of a circle, which is pi r squared, right? And that would give you the area of the minor arc. So arc. So the degrees, 88 degrees out of 360 multiplied by 3.14, because I said that we should use that for pi, remember? And r is 4, so we need to do 4 squared. The radius is 4 squared, 4, right? Because GC is a radius. HC is also a radius. So whichever one you want to use, it's the same 4. So put that into your calculator. So 88 over 360. Can put it as a fraction, or in brackets, put 88 divided by 360 and close your bracket, okay? Times 3.14 multiplied by, either you put 16 or 4 squared. Depends on how well you can use your calculator. But in the end, 12 should be your answer. So the area of the arc is 12.3 or 12.28. I'm just going to write 12.3 centimeters squared, because it's area, right? So you need your units, and it's centimeters, and since it's area, it's squared. So now we have 12.3 cm squared here. Now the shaded segment, the area of the shaded segment down here would be the area of the triangle minus, or the area of the sector minus the area of the triangle. So we're basically going to take out the triangle out of the sector. So that's how we're going to do this. So the sector is 12.3 centimeters squared. Subtract 8 centimeters squared. And that will give you the shaded region. So the area of the shaded region would be equal to 12.3 minus 8, which is 4.3 centimeters squared. So there you go. There you have it, 15 marks, just like that. Okay. So let me just check back something. 88 out of 360, ensure that I didn't write the wrong number because, I'm prone to that. So 88 over 360 multiplied by 3.14. Because somehow I feel like I placed the pi symbol instead of using 3.14. I did not. 12.3. I am correct. Okay, so that's the last question. And we're done for the day. I know I maybe held you for more than an hour, but I know it's not more like wholly more than an hour. I hope this was helpful. Again, if you need to contact me, here you go. Credentials, younggenius.educate@gmail.com. That's the email address. 876-501-1966. That's the number to contact. Facebook, Instagram, developing Twitter, but not active on Twitter yet. So if you message me on Twitter, wait, you can message people on Twitter. I've never used Twitter. Let me just get that out there. Instagram, Facebook and thing, young_genius.official. YouTube, Young Genius Official. Leave me a comment, right? And the website, younggeniusofficial.com. And also go follow me on Instagram. The QR code is right there. And remember earlier I told you that sexy past papers are available on my website. So go over there, younggeniusofficial.com, and do the thing. Share it with a friend who might need it, okay? So until next week, bye guys.